Let's consider a simple circuit. So let's go ahead and talk about this first. In this figure that we are given, we have an electromotive force using battery or generator. It produces a voltage of E volt, and the unit volts denoted as V, and a current I in ampere at time t. The circuit is also contain a resistor, so this is the resistor, with a resistance of R equal in ohm unit. So this have a unit ohm, and it denoted by omega. And the inductor with a reductance L of Henry. The Ohm law gives the drop in voltage due to resistor as R times I. The voltage drop due to the inductor is L times di dt. And one of the Kirchhoff law say that the sum of the voltage drop is equal to the supply voltage E. And so we have this equation L of di dt plus Ri is equal E of t. So this is the first linear order differential equation given at the current I at time t. So suppose that in the simple circuit of the figure, the resistance is 12 ohm and the inductance is 4 Henry. If the battery give a constant voltage of 60 volt and the switch close when t equals 0, so the current start with I of 0 equals 0. First, we want to find the integrating factor M of t. Then we want to find the current after 1 second, and we want to talk about the limit value of the current. Okay, so let's plug every information that we have into this equation. 4 di dt plus 12i is equal to 60. Okay, this means di dt plus 3i is equal to 15. So the integrating factor mu of t equal e to the integral of 3 dx equal to e, and this is in terms of t, so 3 dt, e to the 3t. Multiply this into our differential equation. We get e to the 3t di dt, or let's call this I prime, plus 3 e to the 3t times I equal 15 times e to the 3t. So e to the 3ti is equal to the integral of 15 e to the 3t dt. That equal to 5 e to the 3t plus c. So I is equal 5 plus c divided by e to the 3t. So we were told that I of 0 equal to 0. This implies that c is equal to 5. C equal to negative 5. So we have the differential equation I of t is equal to 5 minus 5 times e to the negative 3t. Now we can solve part B. What is the current after 1 second? I of 1 is equal to 5 minus 5 times e to the negative 3. This is about 4.75 amps. Let's talk about the limit of the current. Well, the limit of the current, we have the equation for the current, part C. I of t is equal to 5 minus 5 times e to the negative 3t. So what happened as t go to infinity? We can rewrite this as the limit at t go to infinity. The 5 minus 5 divided by e to the 3t. At t go to infinity, e to the 3t become extremely large. So this term here go to 0. So this equals 5. So the limit of the current is 5 ohms.